Hi guys, welcome to the notes for 6-9. Today we are going to focus on half angle formulas. Yesterday we did the double angles. The day before we did the sum and difference formulas. So this is just that third set of angle formulas that you're learning. Let's start out here. It asks us to find the value of the sine of half of theta. Okay, so we are going to derive the formula today like we did with the double angles. Okay, and in fact, we're going to use one of our double angles to actually derive it. So let's start out here we have our cosine of 2 theta, right? Remember, there were several versions of this one, right? We're going to use the 1 minus 2 times the sine of theta squared. Okay, so hopefully you remember this one from yesterday. Okay, now when you think about it, the ratio between this and this is already like a half, right? Except it's doubled. We're saying that her theta is doubled. Okay, so what we're going to do here to help us derive our formula for when we're taking half, which is like the inverse, right? If you're doubling something, you take half is like the inverse. So what we're going to do is we're going to just start out here. I want you to just cut each angle in half. Okay, when I do that, right, it's like I'm taking each of these, like I'm dividing this by 2, I'm dividing this by 2. So now really we still have, one is still twice as big as the other, or one is still half the size of the other one there. But we have the cosine of theta equals 1 minus 2 times the sine of half of theta squared. All right, so because we're thinking about this kind of as being like inverses, we are going to do kind of what you do when you find inverses, is we're going to undo everything and move it to the other side of the equation. Okay, so we're taking everything from the right side and we're going to move it to the left side. So the first thing we would do is, we've got to get rid of this 1 here, right? We're going to subtract it from each side. So now we've got the cosine of theta. And we'd say, right, that's where that minus 1 would go on this side because we've subtracted it from each side. And we have negative 2 times our sine of half of theta squared. Okay, the next thing we would have to do is get rid of that negative 2, right? So we're going to divide each side by negative 2. All right, divide the side by negative 2. Okay, well, I don't want to end up recopying it down there. I don't like having just like a monomial on the bottom, a negative in the bottom. So just think about that, right? If we took that negative off the bottom and put it on the top, we'd have a negative cosine of theta minus 1 on the top, and we can just distribute that through, right? So I'm taking the negative out of the bottom and moving it to the top. So what that ends up being there is, since we have a 1, I'm going to do 1 minus my cosine of theta over a positive 2 now equals our sine of half of theta squared. And obviously the next thing we're going to do is we're going to take the square root of each side to get rid of the square. All right, and we know that on the right side we should have the absolute value of the sine of half of theta, and then that's going to lead us to have our positive or negative. I'm going to go ahead and just write the positive or negative on the other side. Okay, so we're going to do positive or negative square root of 1 minus cosine of theta over 2, right? And we say that equals, so we take sine squared and we take the square root of it, we're left with the sine of half of theta. And hopefully you're noticing it, right? That's what we were trying to get to. Okay, that's what we have here. So what you found here is our formula for the sine of half of an angle. Okay, so notice it's plus or minus, and that's going to vary as you go through different problems and things there, and we'll talk about that here as we go through. Okay, so you'll see this same formula on the next slide, right? It's our first formula there on the left. The sine of half of an angle is equal to the positive or negative square root of 1 minus the cosine of A over 2. And then I also am giving you your cosine of half of an angle. And notice really the big difference between our sine and our cosine and the formulas there, right, is simply that sign right there. Everything else is the same. And then obviously you have to pay attention for like positives and negatives, right? We know that the sine function is always positive in our quadrants, what, 1 and 2? And then for our cosine formula, figure out like whatever our angle is, right? Our cosine is positive in quadrants 1 and 4. So it's just something to keep in mind as you're working through the problems today. Okay. Now that part's easy when you know the angles at the start, but sometimes you'll do some stuff with unknown angles like we've done in the past couple days. First problem, find the exact value of the cosine of 67.5 degrees. Okay, this is not one of our familiar angles that we're used to working with, so we're going to look at this as using a half angle formula, right? So finding the cosine of 67.5, can't really do that right now, in terms of finding the exact value. So what I would do here is I would say, let's figure out what twice that angle is, right? If I said 1/2 of what angle is going to be 67.5, and I know this is easy and you guys know you're going to multiply by 2. I'm just doing this now here with degrees because we'll do the same thing with radians when it looks a little bit more confusing. So we know that angle that's twice as big as 67.5 or 67.5 is half of 135 degrees. So, okay, Mr. Boyd, why are you doing all this? Well, we're going to do, instead of the cosine of 67.5, we're going to do the cosine of 135 degrees divided by 2. Right now it looks a little bit more like our formula here, the cosine of theta divided by 2. And that equation, and you can refer back to that math notes box if you need to, right, is going to equal positive or negative square root of 1 plus the cosine of theta over 2. So we are going to take this and we are going to plug it in and solve in this other equation. So let's get started here. Okay, so I'm going to just recopy this down below. Cosine of 135 over 2. Okay, now obviously then, what is theta? Well, theta is 135. It's not our given angle, it's the angle that we are cutting in half. Okay, so that's why we have that 135 in there. Okay, now is this one going to be positive or negative? Right, which of these is it going to be? Well, since the angle is given, right, the angle that we're finding the cosine of is 67.5. So if it's 67.5, we know that's going to be in quadrant number 1, right? It's up here in this quadrant. And we know cosine's positive up there, so we're focused on the positive, right? So this is like the positive one. You don't have to even write the plus sign in there, but just making sure everybody understands. So now we've got 1 plus the cosine of 135 degrees all over 2. And what's left here is to take this and simplify it down. So here we go. We're going to say we've got the square root of, well, 1 plus cosine of 135 degrees is going to be negative radical 2 over 2, right? You can just look at your unit circle for that. And then that's still over 2. But we want to simplify it, so we don't want to leave a fraction in a fraction. So let's go ahead here and get rid of it by multiplying by 2 over 2. Right, that should give us, right, and you're going to multiply all of this by that 2, right? So you're distributing it through. So you're going to have the square root. 2 times 1 is 2. And then positive times negative, we know this is going to become a minus. And then we'd have just a radical 2 left over. And on the bottom, we're going to do 2 times 2, which is going to give us 4, which should allow us then to just simplify it a little bit more, right? We've got the square root of 2 minus the square root of 2 over 2. And this looks like that would be our cosine of, remember, 135 divided by 2 is really cosine of 67.5 degrees, which should equal the square root of 2 minus the square root of 2 over 2. Okay, so let's check here to make sure it's right. Grab your graphing calculator out. Okay, we're in degrees, so let's make sure you're in degrees. Got mode, I've got degrees, we're good there. All right, so the first thing here, we're doing the cosine of 67.5. Go ahead and get that value. Looks like it's about 0.38268, yada, 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 right? Okay, now let's go ahead and type in our answer. We have alpha, let's put our fraction in. Right, we're going to do second square root. We're going to put in 2 minus, and then we have to put a square root inside of our square root, right? I don't think you've ever done that before, but that's what it looks like, over 2. And then when we hit enter there, notice it's the same value. That's a good thing, right? That means we got it right. Let's move on. Okay, so let's do one with radians now. Find the exact value of the cosecant of negative pi over 12, right? Not one of our angles that we normally recognize. So what we're going to do here is we're going to say we've got, what is 1/2 of what angle, right, would equal negative pi over 12? Well, same thing, right? You just multiply both sides by 2. You'd have negative 2 pi over 12, which would reduce to negative pi over 6, right? So taking the cosecant of negative pi over 12 is the same thing as taking the cosecant of negative pi over 6 divided by 2. Now, we know that we don't normally deal with cosecant. Instead, we use our reciprocal function, right? Our sine function. That's the one that's easier for us to use. So we know that this is like saying, this is like 1 over the sine of negative pi over 6 over 2. There, just like that, right? So let's just do this. Let's just find the sine of that negative pi over 6 over 2, and then we're just going to flip it, right? Just remember to flip it. Maybe put a little special thing on your paper there to remember to flip it to get your answer. Okay, so we know that this formula, right, if you need to write the formula, the more times you write the formula, I think the easier it is to remember it. But we've got our sine of theta divided by 2 is going to equal, right, positive or negative square root of 1 minus our cosine of theta over 2. And don't worry, you'll have your blue resource page with you if you can't remember that. You just need to make sure you remember when you're supposed to use it. Okay, and when we look at our first angle here, right, remember it's a given angle, right? So this makes this part with a plus or minus a little bit easier, right? Negative pi over 12, okay, is going to be down here in our fourth quadrant, right? So in this case here, our sine and our cosecant are both negative down in this quadrant, right? So we're going to take it and we are going to make this a negative square root of 1 minus the cosine of negative pi over 6. Okay, and then that's all over 2. All right, now it's just the simplifying game. So we'll just take this and say, all right, 1 minus cosine of negative pi over 6. Well, negative pi over 6 is going to be down here as well, right? It's our pi over 6 angle in quadrant 4. So when we do that, we should have the square root of 3 over 2. So we have 1 minus our square root of 3 over 2, and that's all over 2. And now it's like the same thing we just did, right? Let's get rid of the fractions within the fractions by multiplying by 2 over 2. We'll distribute it through the top. So when we do, we're going to have a 2 minus the square root of 3 over 4. And since that is a perfect square again on this one, right, we'll just go ahead and take the square root of it. And we've got 2 minus the square root of 3 over 2. But that was our sine, right? This is our sine function. So to get our cosecant of what we started with, that negative pi over 6 over 2, which is really the same thing as the cosecant of negative pi over 12, is going to be, right, it's not this, right, because we're going to take it, we're going to flip it. We're going to flip it over. Don't forget, right, we said we were going to flip it, so we're flipping it back. We have a negative 2 over the square root of 2 minus the square root of 3. And that is our answer. And this one can be checked too, right? You can take it, put your calculator in radians and plug all that in. To keep the video shorter, I'm not going to do that part of it. But if you need help with that, just let me know on Monday and I'll help you out. All right, so let's go on to one now where we don't know the angle measure. We just know some characteristics of it. So we've got the cotangent of angle A is equal to 3 over radical 7. And we know that angle A is between pi and 2 pi. So this is telling us this is quadrants 3 or 4 is where angle A lies, right? And, right, since the cotangent's positive, right, that means that our tangent of A is positive, which means we are in quadrant number 3. Let's just go ahead and draw it. Right, there's our coordinate plane. Let's draw in our bow tie in quadrant 3. And if our tangent is radical 7 over 3, remember that's our opposite over adjacent. So our angle opens to here. We'll call it A there. And that means this is radical 7. This is 3, right? But in order for it to be in the third quadrant, we know that this has to be negative. That has to be negative. And now what we need to do is we need to find what our hypotenuse is. So go ahead and do your Pythagorean Theorem. Negative 3 squared plus negative radical 7 squared equals c squared. 9 plus 7 equals c squared. So it looks like our c is going to be 4. Okay, so we'll throw that in there. All right, sounds like my battery's just starting to get low in my AirPods, so I'm going to work through this the best I can, as quickly as I can. All right, so we have the sine of half of our angle. Okay, so we're trying to find sine of half of A. So first thing, right, we already have written down the formula several times, and we can write it down again. But the first thing I'm talking about here is, since we don't know what A is, we know that A is in quadrant 3. Okay, right? It's this angle that opens all the way to here. And we're going to be trying to find the sine. So if you think about where half of this angle would be, half of this angle is probably somewhere in quadrant number 2, right? So when you think about it, where is sine positive? Sine is positive in quadrant 2. So, sorry guys, I think my battery died and I had to redo this here. So I think I should be good now. All right, so we were just talking about half of angle A was in quadrant 2 as we were starting to get ready to use our formula. So if half of angle A is in quadrant 2 and we're talking about the sine, that means when we're writing out our formula, we're going to be using the positive, right? It's going to be a positive sine value, so we don't need that negative. And then the rest of our formula for sine we know is 1 minus the cosine of our angle A over 2. So what we're going to do here then is we're going to figure out what is our cosine of angle A. And since we've already drawn it out over here, right, we know that we need the adjacent and the hypotenuse. So our cosine of A is going to be -3/4. Okay, so we're going to just substitute that in. So we're going to say the square root of 1 minus a -3/4 over 4. And when we take it and we get rid of our complex fraction, right, we're going to multiply by 4 over 4. Actually, why did I write 4 in the beginning? Geez, sorry, I don't know what I was doing there. That should be a 2. So we're going to multiply by 4 over 4 still, right? But we multiply by the 4 because we're trying to get rid of this 4 out of the denominator. So what we've got when we do that, we distribute it through. So we're going to say 4. Now the negative times the negative we know is going to give us a plus, and then we'd have a 3 over 4 times 2 is going to be 8. So we're looking at the square root of 7/8. And we'll just take this and clean it up here, right? So this is like saying the square root of 7 over the square root of 8. And we know the square root of 8 is really just 2 radical 2. So when we rationalize our denominator, it should be a little easier. Just go ahead and do square root of 2 over the square root of 2. And we are looking at the square root of 14. And then we'd have 2 times the square root of 2 times the square root of 2, which should be 4. So we're going to get that equals the square root of 14 over 4. All right, so now we know the sine of half of angle A is going to be the square root of 14 over 4. Okay, so let's move on here. Oops, I didn't clear this part out, so let me clear it out real quick. All right, so let's look at cosine of our half of angle A, right? So this one, again, we're using our half angle formula. Now let's think about where that half of that angle, if half of that angle is up here in quadrant 2, okay, that means that if its cosine is in quadrant 2, that we're going to have a negative value, right? Because cosine's negative in quadrant 2. So as we're writing out our formula, we're going to say negative. We've got square root. And in this case here, right, we're going to do 1 plus our cosine of angle A all over 2. And our cosine of A hasn't changed. So as we take this and we plug it in, we have a negative square root of, we've got 1 plus a -3/4, I believe is what it was, all over 2. And now when we take it here, we will again just go ahead and get rid of complex fraction, multiply it by 4 over 4. So we're looking at a negative square root of 4 plus -3 over 8. And that's going to give us a negative square root of, what, 1 over 8. And we can just go ahead there and reduce it down. You guys know how to do that there. Square root of 1 is 1. We have 2 radical 2 on the bottom. So when we rationalize our denominator, we should get a negative square root of 2 over 4. So our cosine of half of angle A is going to be a negative radical 2 over 4. And then this one's very similar to what we've been doing the past couple of days. Now we've got cotangent, so we know that that's going to be equal to the cosine of half of angle A over the sine of half of angle A. So we'll just take it and we'll substitute those in since we know those, right? We're going to have a negative radical 2 over 4 over, what was our last answer? Radical 14 over 4. Right, is that right? Yep. Okay, so as we do that there, right, you can keep, change, flip, or realize that, hey, they're both being divided by 4, so you multiply them both by 4, and what you get is negative radical 2 over radical 14. And then we'll just rationalize our denominator, right? We could say times radical 14 over radical 14. And that would be what? Negative radical 28 over 14, which is going to reduce because that's 4 times 7. So negative 2 radical 7 over 14. And I believe we get negative radical 7 over 7 as our final answer. However you wish to rationalize and reduce there, whatever works for you, works for me. All right, I appreciate your hard work. While I'm gone, I'll answer any questions you have over this section and the previous section when I return on Monday. Please behave and be nice to the sub. Thanks. Bye.